Hi everyone. These are two examples of Boyle's law problems. Here's the first question. A gas with a volume of 1.35 liters has a pressure of 80 kilopascals. Determine the pressure if the volume expands to 2.50 liters. When we encounter a problem, I like to say that there's three approaches that a person might take. The first thing is they might dive right in. You might feel so comfortable with the formula, with the wording, with everything about the question that almost automatically you just know what to do and you find yourself diving in. That's our favorite thing. I know what to do, I'm moving forward. A second strategy is sometimes it's worth it to just slow down. It might be your personal style to put some labels right into the question. A gas has a volume of 1.35 liters. Oh, that's the volume. Oh, and that's also the initial setup. That's before the volume expands. In the beginning, it had a volume of 1.35 liters. It might be your style to put a little label right into the text of the question, V1 for 1.35 liters. And it has a pressure of 80 kilopascals. That's P1. Those labels might not be necessary for you. You feel comfortable and you're diving right in, but that might be your style or might help you to wrap your head around what's going on with the question. We're going to determine the pressure. Well, we ourselves need to find the pressure. We're looking for P2, and I'm putting a question mark. We don't know what the second pressure is. If the volume expands to 2.50 liters. Look at the connection there. We started at 1.35. It's going to expand, okay, so that implies the volume's going up to 2.50 liters. All that's going to register in our minds really quickly, but it all makes logical sense. So this is V2. We have P's and V's. This is a Boyle's law question. You might be your style to put the formula down. P1, V1 equals P2, V2. You don't have to do that, but it might help you to feel organized. And we're looking for P2. We have this equation, we need to manipulate it. In order to isolate P2, we need to divide both sides by V2. That's going to give us P2 is P1 V1 over V2. Again, we don't have to show our work like that. However, it might be your style, it might help you to feel organized. P1 V1 divided by V2. Let's substitute the values in. P1, it's 80 kilopascals. V1, 1.35 liters. This is divided by V2, 2.50 liters. I notice that the units all match. Both of the volumes are in liters. That's good. The pressure that was given to me was in kilopascals. That means my answer is going to come out in kilopascals as well. Or I see that these 2 liters are going to algebraically cancel off, leaving me kilopascals. Also in the back of my mind, I'm thinking, oh, Boyle's law is an inverse relationship. Here we have the volume go up. That means the pressure goes down. I have built into my mind this expectation that the answer is going to be less than 80. I'm not exactly sure what it is, but I know that if somehow my calculator gives me a large answer, I maybe hit a wrong button or something like that. So I do my calculation. 80 times 1.35 divided by 2.5. 43.2 is what comes out on my calculator screen. That's the raw answer. I need to now think about my significant digits and the units. Here in the question, there's 3 different numbers. 1.35 has 3 sig digs, 80, just 2, and the pressure, 2.50, that's 3 significant digits as well. So I have a couple numbers with 3 sig digs, but the 80 only has 2. That's the least. My answer must have 2 significant digits. Here, it's 43. And we found the pressure, and I notice that the liters here are going to cancel off. It's going to give me kilopascals. That's my final answer. A second example, a 700 milliliter container of gas has a pressure of 140 kilopascals. What volume would it occupy at SATP? Same sort of thing. I need to take my time. If I feel comfortable, I can dive right in and move forward. However, it might feel worth it to slow down and throw some labels into my work. A 700 milliliter container of gas. Oh, that's the volume. It's milliliters. That's the initial setup. V1, 700. And it's in the same sentence. It had a pressure of 140 kilopascals. That's P1. What volume would it occupy? Oh, what volume would it occupy? That's V2. Question saying, can you please find V2? And look how it stands out. It jumps right out. It's in capital letters, SATP. We have these standard conditions, STP and SATP. Each of them is associated with a temperature and a pressure and a molar volume. Because this is a Boyle's law question, all that matters is the pressure, because the temperature is constant during Boyle's law. And the temperature is constant at SATP, but here, what's the pressure for SATP? It's 100 kilopascals. Having SATP as part of the question, it's a shorthand way, it's an indirect way, it's a slightly annoying way of letting me know that the pressure became 100 kilopascals. So now I move forward with my calculation. Maybe I feel comfortable with the whole formula. I don't need to write it down if I don't need to. There's the main formula, Boyle's law. I'm trying to solve for V2. It's P1 times V1 over P2. Now I can start to substitute values in. I have my nice labels. They're going to come in handy. P1, that was 140 kilopascals. V1, the initial volume. (700 milliliters) divided by P2. It wasn't specifically told to me in the question. I had to do a little bit of extra thinking and interpreting this SATP. The pressure is 100 kilopascals. Okay. It's all set up. When I reflect and just look at my work, the kilopascals are going to cancel. It's going to give me my answer in milliliters. In addition, I noticed that the pressure went down. It went from 140 down. If the pressure goes down, what happened to the volume? Oh, Boyle's an inverse relationship. So I have this expectation that I should have an answer larger than 700. And when I do the math, 140 times 700 divided by 100. Comes out on my screen is 980. This is the raw answer. I need to think about it. The values specifically printed in the question each have 3 significant digits, so my answer should have 3 digs as well. Pardon me, it does. 980. This is the volume. Notice here the kilopascals are going to cancel off, and it's going to leave me milliliters. As long as the units match, I'm good. I shouldn't really find myself doing much unit conversions when I'm working with Boyle's law. Look at the first example. The 2 volumes were in liters, and that's okay. They match. Those end up canceling, and look at those 2 kilopascals, they match as well. In the second example, the volumes were both in milliliters. 700 milliliters, 980 milliliters, that's okay. As long as they match, we're good. When we're working with Boyle's law, you might find it useful to put some labels right into the question. If you're feeling comfortable enough diving right in, that's fantastic. Watch out for those times where we have SATP or STP. That's an indirect way of letting you know something about the temperature or the pressure, or eventually something about molar volume. And I hope that helps.